US. And if you think about what are they going to do after they graduate, a very large, significant amount of them are going to end up working in industry. A small fraction will go to grad school, medical school, and other professions, but there is a very large number of them that will work for industry. So when we talked about is there a need for a change in the way that we conduct education, we should also ask employers of these students, what do they think? Is there a real need for a change or not? We should think about that and not only be concerned about those who are going to continue into grad school. So in order to address that, we have 3 people that were listed originally in the agenda, plus we have an addition to our panelist group. So 3 of them have actually scientific background, and one is more of a person with an MBA and other kind of degree. So let me introduce very briefly. You can read the biographies in the booklet that you have. But the first person that we have is Shannon Bullard. She's an HR and program manager for DuPont Chemicals and Fluoroproducts, and she's part of the technical organization and been working for DuPont for a significant number of years. She got a BS in food science from the University of Delaware and then got an MBA from Drexel. Next to her is Francine Palmer, and she works at Solvay Research and Innovation and is the director for North America. She got a PhD in organic chemistry from the University of Adelaide in Australia, followed by a postdoc at Exeter. And in her current role, she's responsible for key competencies and talent management and recruitment. So she's the right person to participate in this conversation. Then David Harwell, who works for the ACS, is Assistant Director for Career Management and Development. He has a PhD from Texas Tech University, followed by a postdoc at UCLA. And finally, I have Robert Peoples, that I have known for about a year or so. He is Mr. Green Chemistry and now works for CARE, which is a company that's devoted to recycling carpets and making money out of that. With that, what are we going to do is we're going to have a brief statement by the 4 panelists, and then we'll open up for questions from the public. So, Shannon, all yours.
Thank you. So, starting out, I guess a little bit of an introduction and why is a food scientist with an MBA sitting up here on the panel. So my degree is in food science. It seems as though I may have taken more organic chemistry than current chemistry graduates because I've definitely taken 2 semesters of organic. Actually, I think I might have taken 3. So anyway, and then I started out my work in the lab as a bachelor degree scientist, working for DuPont in 2002. I've really kind of fallen into human resources because I've been really passionate about recruiting, and I've been leading DuPont recruiting programs for what we call associate investigators, which are bachelor degree scientists and engineers coming in to work in the laboratories at DuPont, both in our long-range research organization and in the businesses. So that's a little bit about myself. A little bit about some of the places that I have some passion, the things that I think are important, where do I find opportunities, is there a need for change? I guess to start out with, no, there's not a need or an urgent need or a burning platform that we need to change. However, I think there are some opportunities, and a lot of them came up in this morning's earlier talks. Some of the things that I find pretty important for our graduates and what I look for when I'm hiring these folks, technical flexibility. I think that I can't focus on that enough. You know, working in industry, we need folks that can do the work in a specific area, but when customers drive our changes to other products, our associate investigators need to be flexible enough to also do that. DuPont as a company has moved over the course of our evolution from being more of a, gunpowder company to a chemical company to now we're an integrated science company. So we need folks that are scientists that understand how to think and that have that technical background and that inquisitiveness, but not necessarily so focused on a particular discipline, say organic chemistry or inorganic chemistry or what have you. The other piece goes along with that, which is the ability to think and problem solve. So looking at the big problems around feeding the world, fueling the world, and protecting folks. Looking at those and trying to solve the big problems. And finally, the one comes back to, we talked a lot about internships and research, undergraduate research. That's another point I can't emphasize enough. The ability, they say a picture tells 1,000 words. Having that experience and putting to practice what you've learned in the classroom is invaluable for these students, and it prepares them so much more coming into industry. So that's another point. It really helps with troubleshooting ability, so they get into labs, they understand what to do when something fails, and they can troubleshoot. It kind of helps with that problem solving and thinking, and just helps them commit to practice the things they've learned. So I've probably said too much already, so with that I'll turn it over to Francine.
So hello, my name is Francine Palmer. What I would hope to do in my few minutes, and I'll try and keep it brief, is to give a little bit of background of myself, a bit of background of Solvay, who I believe not a lot of people are familiar with, certainly in the States, and then give a piece of my own perspective. So as you heard, my education was in Australia. I did some postdoctoral work in the UK, and then moved from fundamental research in pharmaceutical area across to the dark side, and came into the chemical industry, the specialty chemicals industry, which a lot of the people that I graduated from very fundamental scientific research, I guess didn't always see what the scientific challenge was in that. So one of my ambitions is to promote the value and the creativity that is a part of the chemical industry today. So that's myself, that's my little soapbox. In terms of Solvay, so Solvay is a global company. It's a Belgium-based company. It is today the combined company of the Rhodia legacy, which has probably had as big a presence in the US as well as the Solvay legacy together. It's a $2 billion euro organisation. The R&D budget for the global R&D budget is about $340 million. In the US, approximately 20% of the group's sales are in the US. We have 2 major research centres housing about 250 scientists and a number of different satellite sites as well. So that's a little bit around Solvay. The areas that we contribute to from an innovation perspective as well as sales are really vary across the large market space, from consumer chemicals to the energy markets to agrochemicals. There's a very broad perspective in there. The main thing that is of value for Solvay across the organisation, not just in the sciences or in the research group, is that we are focused around a culture of sustainability, innovation and operational excellence. So for me, the conversation today feeds into every part of that area within our organisation, not just in the research group, but a lot of our researchers transition into other roles and other leaders within the company for the future. So that's one important point as well. In terms of the topic of today, being around the undergraduate education, I think the two most important points for me are, the first one is the fundamentals are still key. The basic science, basic chemistry fundamentals are still hugely important. We see, certainly in a lot of our hiring, that there's more and more graduates that are specialising a lot earlier, which limits their potential to learn and grow within an industrial organisation. So that's one thing that's very important. The basic chemistry fundamentals are really important. There's a number of people coming in with biological sciences, material sciences. That's all important. I'm not saying it's not. But a really broad understanding of the chemistry fundamentals is key. The other thing that, that's the first thing. The second point that is most important are the soft skills, which are hard to necessarily teach, but really important to teach. They can come through classes, they can come through extracurricular activities, they can come through internships, co-op type programs. But today, within the candidates that we see, a bachelor degree is the standard, right? That's the baseline. If you don't have one, you don't get in the door. But the students, the graduates, the leaders within our company that do really well are those that have some of those soft skills. So talking about having a bit of a global vision, trying to understand where you fit in the world and what your research and your contribution does, why it matters. Feeding into that is their communication skills. We see a lot of really, really clever students that are unable to put their opinion across, that are unable to formulate their responses, which makes it really hard in a large research community to be able to collaborate, We don't have individual researchers. Everyone's working as a part of a group. That's no different to any other industry or even in academia. But if you can't communicate, can't get across your opinions and how they feed into the larger problem-solving effort, then it's really limiting your potential to grow and to succeed. Thank you.
Hi, I'm David Harwell. So as the person that runs the career programs at ACS, I run into a lot of people with challenges. There are three populations that I'm specifically concerned about right now. That's displaced workers, long-term unemployed, and students. Of those three, students are top, and that's because their unemployment rate is the highest. So if we look at the unemployment rate for new graduates in chemistry, this is across all degrees, so bachelor's, master's, PhD. The average is 13.3%. For chemists in general, if you look at all chemists, then the unemployment rate is 14.6%. So, you know, when I talk to chemists, they think 14.6 is atrocious. It's worse. The worst thing that's ever happened. The world has come to an end. And for them, if they're one of those people that are unemployed, it has. But it's much, much worse for students. And if we look at bachelor's degrees, well, they're higher. So they're north of 14%. So what does that number mean? That means a year out after getting their degree, after graduating, they're still unemployed. And I was at a conference yesterday with several guests from the Department of Labor and different groups, economists, and they're calling the current group of graduates the underemployed generation or the unemployed generation, because for the first time since World War II, we have this huge group of young people that are not finding opportunities. And I know I asked probably some annoying questions this morning. Coming from an academic background, which is where I came from originally, I used to teach at University of Hawaii. My eyes were opened when I moved into the careers office. I thought it'd be easy. I'll just teach people how to do their resume. The unemployment rate was low. Really, there wasn't a lot to do. And then the economy crashed. And then pharma started their mergers and acquisitions. And there became thousands of people now, not in the general population, thousands that I knew, thousands of chemists that were out of work. And so we had to shift our strategy, and we looked into the problem. There are several differences. So let's look at two cohorts. Let's look at displaced workers, who that's our code word for people that have been laid off. So they're experienced people, and their unemployment rate is just a little bit more than 4%. Compare that to students that are at 13, or if we're talking about bachelors, 14.6%. What's the difference? Well, one main difference is experience. All right, part of that, they're just going to have to live. They're going to have to go out, do things, and experience it and gain those opportunities. But they can proactively gain those opportunities by looking for internships. So if they can get into a company, they're getting practical experience. And undergraduate research is good. That's much better than not having it. So if we're looking at the factors that are going to help them get a job, one, get some research experience wherever you can get it. If you can get it in a company, even better. And if you're in a company, the advantage there is, one, you've got the inside track to any jobs or opportunities that may exist, even if they're not published. And you're also going to learn about the culture. So there are things in industry that academics just don't do. I mean, safety is number one, really. Safety is number one in industry. And it's a very different culture. So the first thing that an intern or a new employee is going to do is go through a lot of safety training. In academics, I thought we did a lot of safety training. We do not do any safety training. So it was very different. There are other aspects of of being in industry. So you are always on teams because it's project-based. So, and those teams are in flux. So you may be on the same team over and over again, like a research group at a university, but chances are you're going to be reassigned. You have a certain skill set, and you'll come on to a team to do whatever it is you do, if that's organic synthesis. And then the next project that comes along, they'll pull an organic synthesis person, that may be you, maybe somebody else, into a team that can overall has the competencies to accomplish the task. So the flexibility is key, and that's an important skill set to have, to be able to work on teams, to be able to shift priorities quickly. Also, the other big difference for students between them and more established workers is networks. So just by being around longer, we tend to meet more people and we know more people, right? That's our network. So more experienced people have better established networks. But this is something where students can totally make up the gap. So if they realize that everyone, all the students around them, all the people that have graduated before them are part of their network, that you are part of their network, and all the people you know and your students are part of their network, then they've already grown their network pretty large, and chances are they know the people that have just been hired. So more established people don't necessarily know that. So students can gain in their network power very, very quickly, and that's one of the things we teach them. The other pitfalls that I see is what I call the commoditization of our students. So when they bring their resumes to me for review, and I do a triage. So what they usually do is they say, I've been trying for a year. I've put out millions of these things, and no one's called me back. Well, okay, if we're looking at this from a process point of view, got to be at the beginning of the process. The only thing you've done is found your resume. It must be bad. Look at that. And when you look at it, it's a series of acronyms, FTIR, NMR. They may have a few words like organic synthesis, but they don't explain what they did, what they learned, how they applied that knowledge. And they've got to. It's a sales brochure, right? So they've got to show how they're able to apply that to solve Solvay's problems or DuPont's. And if they can't do that, someone else will. And they're going to be the one to get the job, not this person. So that's one of the things that we try and teach. The other thing is that we bring out those soft skills. Here's an easier way for me to think about it. Hopefully it'll work for you. The soft skills are usually demonstrated through what we call behavioral problems. So somebody in HR will ask a behavioral question of a candidate. Give me an example of a time when you displayed teamwork as to solve a chemistry problem. Okay, so then that helps the students to prepare, because if they know that each one of these sort of soft skills, leadership skills, teamwork skills, is going to be presented to them in terms of a story, well, guess what? They need to have a story ready. Tell me, have a story ready that will explain how you're able to demonstrate teamwork, how you've led a research effort, how you did these different things. And that helps them to also show how they were able to apply their competency set, not just have it. So instead of being FTIR on their resume, they can actually explain how they used an FTIR to find the hydroxyl group on a particular compound and identify its structure. So I'll stop there, and we'll go to Bob.
Thank you, Dave. Well, one of the advantages of being a late addition and at the end of the table is I could say I agree with everything my fellow panelists have said. So, but I do have a few thoughts to share. My background is physical organic chemistry, 3 years working for a major international corporation, Monsanto, and its spin-off Solutia. And you know, I started in 1979, so the industrial chemistry world has changed dramatically over that period of time. And going through a spin-off teaches you a lot of very valuable and then sometimes painful lessons about what it's like out in the industrial side of the real world. But as I thought about this over the last few minutes, a few things that hit my mind, because this is focused on undergraduate. So I would say the advantage on the PhD side is you're looking at candidates that are highly specialized in an area, demonstrated skill sets, and they're hired to match a specific need. At least that's the way it typically starts. You're looking for a general match, but they have a degree of training and networking and such that's not an issue. When we come to the undergraduate level, in my current role, I work with both small and large companies all across the United States and internationally. And I hear from them constantly about the undergraduate resource pool. You know, sometimes the word is technician is used, but it's the not the master's or the PhD level, but it's the undergraduate level. And without repeating a lot of the things that Dave said in particular, the number one issue that seems to come up is safety. You know, they get virtually no real appreciation for a safety culture. So I know the agendas are full, but safety is really a culture. It's not a one-semester course that you take. It's something that should be built into, you know, the culture of the organization from day one. And once they've been exposed to that for a period of time, it becomes second nature. That's what culture is all about. A lot of the companies I've talked to have said they've accepted that they have to invest time and energy in developing training courses for the people that they bring in because they feel they don't have the necessary skill sets to function at the level that they're desired. That training starts with safety. It deals with cultural norms, which is normal for entry into any new company. But they also get specific training in equipment and operations, which they're not exposed to at the undergraduate level. And I guess the comments have been made is that undergraduates have an opportunity to participate in a co-op or an intern program, come in with a higher set of skills, but maybe also, more importantly, a context in which their training and their skills can be applied so they understand the concepts of teamwork and collaboration to deploy those skills. One of the things that I've always felt strongly about is in the undergraduate curriculum is build time through a seminar program or guest lecturers in your lectures to bring in industrial scientists. And when I say scientists, I don't just mean chemists. I mean chemists, I mean engineers, I mean environmental scientists, I mean toxicologists, because you know, I think it's important that the students get exposed to a broad set of context in which they're going to operate. I gave an example earlier when we were talking over lunch that, you know, a lot of times the way we teach, especially at the undergraduate level, is that we teach a course on a hammer. You know, we can fill a whole semester with what a hammer is, how it's designed, how you use it, and another course on a level, and another course on a saw. But none of those things mean anything until the students take the practical course on how do you build a house, because then all of the contextual applications for these skills come into place. The other thing is that students they're so concerned with all these standardized tests that there's rote memorization to respond to the questions. And what they lack is the development of the tools, the techniques, and the personal confidence, how to tackle a problem, right? And how to tackle a problem, an important part of that learning is not just, I have to have all the answers. An important part of that problem is, here's the problem I got to solve. I figured out how I'm going to tackle that problem. Now I know I'm going to go to Dave. I know I'm going to go to Francine because they bring pieces of expertise that I don't have, and that's okay. I'm being asked to solve the problem. I'm not being asked to solve it in a vacuum by myself. Another element is sustainability. A big word, means a lot of things to a lot of people. It gets abused these days. We talk about greenwashing, but the fact is corporate America is looking for people that have an understanding and appreciation of the concepts and the tools of sustainability. Believe it or not, I think there's a win-win opportunity here because your students actually are coming in with an interest in and a desire to learn and hear about sustainability. So you can deliver to them something that they're looking for, and in return, you're increasing the value of the product that we're producing at the undergraduate level for value out in society. Going to give them an edge over their competition to a certain extent. And maybe I'll kind of wrap up my thoughts is that after 30 plus years, I know I don't look old enough to say that, but it's true. After 30 plus years of running very large organizations, which span, high-level fellow scientists down to hourly wage role people, and working with companies on the outside, if I had to pick 2 words that sum up the most difficult challenges I've ever faced, it's effective communications. I've got examples sitting around a table with a dozen people all committed to solving a problem or launching a product. 3 weeks later, you get back together, Pat, did you do this? Oh, I thought Emilio was going to do that. And next thing you know, things don't get done or they don't get done very efficiently. So communications, the ability to take technical content and reduce it into non-threatening language that you can convey your ideas and concepts and their value to the business community. Because let's face it, all of the wonderful inventions and innovations that we create are of no value to society, to building the economic engine of the United States, to creating jobs, if they don't get reduced to commercial value. That's where we scale. That's where we amplify. But you have to be able to convey that information in a meaningful way to the people that make the decisions. It's pretty rare that a chemist or an engineer makes the final decision to invest significant capital to deploy new technology, to put new products in the marketplace. You got to be able to speak the language of the business community, and that comes down to more or less return on investment. So we've got to learn that language as well as to de-intensify the language of the technical community. And my last thought is this. I don't think at the undergraduate level we take enough opportunity for mentoring. I know it's hard when you have huge classes, but the simple fact is that mentoring has a huge impact on people. And for those that are receptive to it, the return on that investment, both at a personal level and in terms of the product that you're putting out and future career success, I think can be huge.
Thank you, Bob. So the room is open for questions from anybody.
Hi, everybody. Good afternoon. I'm, let's see, I have to look at my name tag. Scott Auerbach from UMass Amherst. Okay, good. It's been a long day. So thank you very much for your thoughts. Actually, this is set from Mark. Jim, can you help me? Okay, perfect. Yes, this is mechanical engineering. So thanks very much for your thoughts. One word that we heard often is the internship word, and I think that's hugely important. And in fact, I would have all my students have as many of those as we can. But if we rely on them to teach students the skills that they need to succeed, that's a cop-out, I think. I think we need to be thinking about how can we create different kinds of educational opportunities on campus that are as close to that as we can. And so that's a little plug for the ICONS program, which you'll be hearing about tomorrow if you stay, and I hope you all will. But the challenge that we have then is, and now I'm going to use sort of like a fitness principle, which is if you want to be, good at running fast, you have to practice running fast. And so that means that if we train our students to swim, but they get to your, companies and you ask them to run fast, they don't have the kind of training that they need. So that means we need to devote credit hours to getting the kinds of training, working in teams, working on big problems, practicing the art of communication, not only to scientists, but to non-scientists. And at the same time, Francine said the fundamentals are important. So you see the problem we have. We want to have our cake and we want to eat it too, and there's only a certain number of hours that we have. So the fundamental decision that we have to make is, what's the critical mass of time that we need to be spending teaching? And I have to say, I don't like the word soft, skills, because it sends the message they're not, important. I don't know what to call them, but there's a critical mass of time that we need to spend, teaching those, and that needs to be built into the chemistry curriculum. What is the critical mass? And it's not on you to figure out what we need to leave out, but I do say it is on you to tell us what that, critical mass of time is.
Thank you, Scott. One thing that I'm reflecting upon, having the cake and eating it too, and I agree. I have here in my notes, fundamentals are key. Don't lose focus on the fundamentals. And yet I'm also saying we need all of these I'll call them collaboration skills. And I think one approach I would suggest is think outside of the box on how to solve that problem. It's not necessarily one at the expense of the other. It's how do you teach differently, or how do you engage your students differently in order to have them learn both at once? Because I do believe it is possible. I don't have a solution necessarily, but I also think that perhaps there's an opportunity to look at other disciplines and see how have they done it. I know my own personal experience coming up through food science, which is an applied science, I think they did a fair job of encouraging us to work kind of on an interdisciplinary team throughout my undergraduate experience. And the other place to look, where I'm sure that all of you work closely, is within chemical engineering. They do a pretty good job of emphasizing those soft skills and the industry skills, and yet my opinion is they haven't lost focus on the fundamentals. So there may be opportunities to learn from them, take what they've done, and make it even better and apply it to yourself.
May I add something to that? I agree with all of the comments, and I do definitely not like soft skills. It's indoctrinated in me now from work, but soft skills is not right. Maybe non-technical skills. One of the things that I would like to share, and I don't know the politically correct way to say it, so forgive me if it doesn't come across in the right way. One of the challenges that we have is that the students that we receive feel entitled that they're going to be given everything. So in a part of the conversation that we've just heard then, you hear how do we help them learn it more, how do we include that in our curriculum, how do we make sure they get everything, both the fundamentals. You know, maybe a part of the conversation is you need to take it upon yourself to find a way to do it in what we're providing for you. So really encouraging the students to take ownership for the challenge, because when they come into our workplaces, that's one of the soft skills that we struggle with, which is that a lot of the students are not proactive in this. They may be proactive in the sense of, yes, they'll go and read the literature about what you've told them they need to understand, but they're not necessarily proactive in trying to understand how they can help themselves, which feeds the whole conversation around communication, project work, collaboration. It feeds all of those things if they go out and try and do it themselves. So expecting them to have ownership of the problem is a part of the challenge. And shame on me for not mentioning safety earlier in my conversation, so I apologize for that. It's here. If I can show you my page.
Safety first.
But one of the things I would say, when we talk about the intern programs, co-op programs, I'm not speaking for everyone in Solvay, but my personal point is I actually don't really care what they do when they come to us, in terms of if I'm looking at a resume and the student can talk about the co-op they did and what the problem was, the chemical problem. That's important, but to me, having exposure to the safety culture, to the culture of the industry is way more important than the chemistry they do when they're with the organization.
So I'll be very quick. One of the things that you might call them foundational skills, because whether you work at McDonald's or at Solvay, you've got to have those skills. And if you don't have communication skills, you're going to be stuck at the fry later because you can't work with anybody else. So if you want to get onto the front line to handle orders of Big Macs, you got to have communications. So they're very foundational. Also, you can think of them in terms of emotional intelligence. And so emotional intelligence is a much better predictor of success, long-term success, than IQ. And you can, for a popular psychology book, if you want to look at Malcolm Gladwell's The Outliers.
Yeah. John Kozarich, ActiveX Biosciences. And since I'm one of the industrial people on CSR, just thought I'd add my 2 cents. And I think what I'm hearing is heading in the direction I was intending to go, and that is having spent a lot of time placing graduate students and undergrads when I was in academia, and then hiring people at Merck, and then for the past 12 years being involved in a company that I helped start up in La Jolla. I do a lot of hiring, and I've done a lot of thinking about how I hire people. And in terms of the topic here, I kind of view that what the CV is your access to get an interview, basically. And in many ways, we can be influenced by a lot of different things. We can be influenced by the types of courses that someone took, the school they went to, the grades they got, that sort of thing, whether how deeply they describe a particular use of FTIR that they used during their studies. But at the end of the day, I always find that the thing I focus on most is in the interview itself. And one of the things I did when I had graduate students and postdocs, I would interview them for jobs as practice. And I just wonder, because all of the other things you guys are talking about are the things that are not on the paper. You know, it's the effective communication skills, it's the teamwork skills, and so on. It's that those extra dynamic that kind of say that this person has got star quality in a way that even if they don't have on paper exactly what you want, they're going to figure it out and get there. And so I'd like your comments on that. I mean, how do we integrate that kind of thinking into undergraduate chemistry education?
Well, let me take a quick crack at that. And I'm going to start by repeating something I think Shannon said a minute ago, and that is, I think you could think creatively how to tackle this problem. So, for example, and if you're interested, I'm going to give you a reference to the Pensacola Naval Air Museum, who implemented I guess it's a one-day boot camp kind of situation where they bring kids in and they have real-world scenarios of crisis situations, and the kids have to figure out what tools they need to bring in. So they're solving problems in a real-world context, but they're learning the basics in the process of doing that. So, I mean, there's theatrical support that's been brought to bear to those programs. You're not going to have access to some of that, but conducting exercises that have real-world situations in which, to our previous speaker's comment, you can build learning fundamentals, okay? So you're doing it in context. The last thing I would tell you quickly is that I had the privilege of running a one-year capstone course at NC State while I worked in industry, 2 semesters. And what we did throughout both the semesters, we periodically brought industrial people in. I brought chemists at the bench. I brought chemists that operated in the plant, engineers, but I also brought in marketing, legal, intellectual property people, and the sales folks. So the students, the challenge they were facing, they got the context of how what they were working on from a basic science point of view fit into a real-world application. And we also offered them the opportunity to have a psychologist sit in the room with them while they made presentations. They were videotaped and given private consulting feedback on their presentations. I know that was an unusual and a unique experience, but you know, it's a creative set of tools that you can bring for an integrated educational approach. And this was an undergraduate program.
Just quickly, I think life's not linear, and education shouldn't be linear either. So it's not that you have to teach things in a sequential manner, but teamwork can be something that you address in the solving of a problem in the context of a course.
Joel Schulman, University of Cincinnati, but let me change hats here and clear my throat. And talk from my former position as manager of external relations at Procter & Gamble. Part of that job entailed technical recruiting. One of the first things that I saw in that job was that students were not prepared for industry, period, whether they're undergraduates or graduate students. And that's why the University of Cincinnati created a position for me when I retired from Procter & Gamble to do that kind of thing, work with graduate students initially and undergraduates, getting them prepared for industry. So there are a lot of different things. Everything that has been talked about here is right spot on. First of all, I would suggest employability skills instead of soft skills or anything else. That's what it is. It's the skills that somebody needs to get employed and be successful when they're employed. Communication's obviously key. CPT recognizes this, and if you look at the guidelines, there are a set of employability skills, professional skills that are delineated, including communications, safety, literature skills, team skills, all of that programs are asked to comment on how they impart and assess those skills in their students. Vital. When I started at University of Cincinnati, I was asked to give a talk about the course that I developed, Life After Graduate School, for graduate students, and it was a group of about 100 faculty members from throughout the university. I mentioned that one of the things I was going to talk about was how to successfully interview for industry. Somebody said, okay, what do you mean? And I said, well, for one thing, industry uses a lot of behavioral interviewing, as David mentioned, and students are not ready for that. Nobody in that audience of 100 or so faculty had any idea what I was talking about. They didn't do it. I think hopefully now, this was 10 years ago, hopefully now they know about it. But as John said, you can train students to interview well. I've done it. I'm sure most of you have done it. If they understand why they're being asked a question and what the expected answer is, they can get there. Same thing with their resumes, as Dave mentioned also. They don't know until they're instructed that what they're trying to do with that resume is convince somebody that they ought to have an interview, to go over the resume and go beyond that. The fact that CPT is now going to be, I assume, mandating capstone experiences in undergraduate education. As Bob said, that can be an undergraduate course that covers a lot of this stuff, or it can be just other kinds of experiences. But it's another way to impart those employability skills. So let me finish with a quick question. Now that I can get off my soapbox. I think it was Shannon that mentioned chemical engineers do a pretty good job of imparting employability skills. That, I think, is one of the reasons that starting salaries for chemical engineers are 50% higher probably than, I don't know, David, what's the number? Do you know exactly? That's a lot more than what a bachelor chemist gets.
I'll tell you in a minute. I think it's 35%.
Oh, okay.
It's big enough
$1
anyway.
here, $1 there. But if you can comment on that and maybe go into a little bit more about what chemical engineers can do that chemists can't when they get employed at the bachelor's level.
At a very high level, the experience or the exposure I've had to the difference between chemical engineers and chemists, we hire roughly 60% of our employees are chemistry of some discipline. It can be applied chemistry. About 20% are engineers. In terms of the leaders that are in the organisation, that's completely reversed. So absolutely, we see that. The biggest differences, very simplistically, is engineers, chemical engineers do a lot of project work. They do a lot of collaborative problem solving within their studies, but not in addition, within their studies. They also are required to do a significant amount of presentation, and most of them have a requirement for a co-op. A co-op or an internship.
And just to build on that, I agree with everything Francine said. One of the things that I see as a difference, and I'm not saying that it's wrong, is the chemists are trained in a lot of times in the independent research and to get deep into what that problem is, whereas the engineers are much more trained in a breadth, if you'll kind of excuse me using the depth and breadth analogies. But they are more interdisciplinary by their nature. They have, not as deep of a chemistry background as your chemist does, but they've also got the training in operations and other facets. And the way that they learn is much more collaborative traditionally. I do think that there's an opportunity for the sciences to become more collaborative, but don't lose the fundamental of what science is and why we do science. And so that's where you end up with the cake and eat it too. Yes, I know. But I think there is a way to collaborate and to build in those influence skills because, as we talked about capital projects, the ability to communicate well is your ability to influence. And without influencing the actions of other people, you have no impact. And that's what basically we're looking for. So.
Quick thought, and that is this. From my experience The thing that really distinguished an undergraduate chemical engineer from a chemist is an engineer comes in and the company knows that they can assign them a problem and the engineer knows how to tackle the problem and solve it. Chemists come in and the expectation is they have to be supervised.
Ann McCoy from Ohio State. As Joel mentioned, CPT is contemplating putting in this capstone experience as one of the requirements. And borrowing from one of Shannon's responses, I'd like to ask you to think outside the box on what such an experience might look like. The more possible ways one can do it and the more effective ways one can do it, I think the more effective such an experience could become for the students.
Can I ask a basic question? What is CPT?
Go ahead.
Thank you.
Well, since nobody jumped up, I'll offer you a thought. Just trying to think creatively here. If you look around at some of the natural disasters that have occurred recently, how do you respond to situations like this? Here's a real-world scenario. You had a hurricane hit the northeast coast of the United States. You had natural gas leaking and fires all over the place. You got chemical contamination from fluids in people's homes, cars that are overturned, and everything else. How would a scientist approach, diagnosing that situation, outlining a plan of action, and implementing that plan of action? Just one trivial example. I think we got gazillions of examples all around us so you could draw upon for that. The other one I'd throw out is that, I'm facing a real-world challenge right now. We don't have enough products or market outlets for polyester face fiber recovered from post-consumer carpet. Man, I'd love to give that to a bunch of students who have no boundaries about this can't be done, Katie bar the door. And, those are the real-world problems I think could really drive home the science that people are learning.
I think another way that you could do it is basically to mimic what would happen in industry. Or you could build it around scenarios. So Bob gave you a couple of scenarios. You have the students work on teams to solve that, and you give them different roles to play. Another way that business schools do it, but we don't do it, is that they do give them a scenario, or they have to come up with their own problem to solve, and they build their business case around that. Could you have them work with students from business or from chemical engineering or from other parts of the university so that they get more of a feel of what it's like to work on an interdisciplinary team to solve a problem?
Perhaps just in listening to that, there's a lot of companies that post challenges online, right? So it wouldn't require work from anyone else to put a program together. You could have your students, right, on a collaborative project, at whatever size your group is, put a group of students together and say, go out and look at the chemical industry's website, find a problem and come up with a proposal, which would then solve the challenge of it's still chemistry, so they still have to understand the technical. It makes them be proactive and go out and find it, and it makes them work together. So maybe that's another opportunity.
Okay, thanks. And the last question, because we are running out of time for this session. Pat?
This is a question for Francine and Shannon. What do you think of the marketplace right now? Is there a glut of chemists? Is there a glut of STEM people? Is there a shortage? Is there a looming shortage? Can you comment on that, please?
I don't believe there's a glut of good scientists, is the way I'll answer that question. In terms of diversity, it's still very heavy in the male domination, absolutely. I had this conversation actually with a colleague at the CCR meeting yesterday. That I find it very interesting in my own professional career that the conversation around diversity is always brought up by a man, because I don't think about it. So I personally don't see that as much of a concern, because if people are trained in the right way, that will come back to being more equal. But that's just my own opinion. In terms of, I forget the third part of your question, I'm sorry, you said diversity, glut, and, did I misunderstand? I apologize, I thought you had a diversity angle in there as well. would you like to address the STEM?
So the glut or the shortage question, I want to echo Francine. I don't think that there is a glut of skilled, qualified chemists. Our requirements for folks that we hire, one of the first ones is a minimum 3.0 GPA, which can be somewhat difficult, and that's one of the DuPont policies. It's not necessarily one that I think should or shouldn't be a hard and fast rule, but it is what it is. So I don't think that there's a glut of good chemists and good students. What I will say, though, to your question, chemistry, sorry, my mic is acting up. Chemistry is something that we found folks really aren't as energetic about as the biological and life sciences as they used to be. And you see it in the chemical engineering disciplines. They're moving much more and more towards the biochemical areas. And you see it with chemistry. A lot of it's moving more towards the biochemical side. And it's not bad, and industry, and my company is one, is moving in that direction. However, there isn't a lot of interest in the industrial chemistry that we still need to be doing. No, from the students and the graduating population, you know, looking into, you know, catalysis for synthetic chemistry for a material isn't as exciting to them.
Okay, let me finish by asking that question, because I'm still wondering how the title of this session is there a need for a change. And actually, after listening to everything that you said, you gave a description of what the ideal candidate will look like, that hard skill, soft skill, and all of that. Is that what you're getting today, or that's what you're missing? Is there a need for improvement in all of the things that you mentioned, or not? That's not clear for me, based on all the discussion this afternoon.
I'll be short. I think there's an opportunity for a change. There's an opportunity to make our graduates more competitive in the world. I think there's an opportunity with Generation Y. So another thing I do a lot of research on in my spare time is generational diversity. And I think that this generation is coming with a set of skills that we can exploit and make them more competitive.
Also, very briefly, I would say that I don't think we need a fundamental change in what is being done today, but I think there is a way to make a much bigger impact with what we're already doing.
Okay. Let's thank our panelists for their participation today.